A very good morning to everybody. Welcome you all for this session 21. In this session, we will study about classical mechanics. In the previous classes, you learned Newton's laws of motion, inertial and non-inertial frames of reference, Galilean transformation, conservation of linear and angular momentum. The learning objective of this session is to understand what do you mean by constraint, the types of constraints, holonomic and non-holonomic constraints. By the end of this session, you will come to know what do you mean by constraint and their types. Newton's second law of motion is given by F is equal to ma or F is equal to dp by dt. Here you observe force, momentum, acceleration, all these physical quantities are in vectors and they need vector treatment. If you don't know all the forces, then solving the problem will become difficulty. Most of the motions are restricted or limited with one or two conditions. Example, motion of a planet around the sun is in a restricted motion. Pendulum with a rigid support is in a restricted motion to move in a plane. A linear harmonic oscillator is a restricted motion to move only along one direction. Atwood's machine, where mass m1 and m2 are restricted to move only along the surface of a pulley. A bead sliding on a curved surface is in a restricted motion. An object moving on a surface is in a restricted motion. Rolling without slipping is also an example of restricted motion. These limitations or restriction on the motion of a system are called constraints, and the motion is said to be a constrained motion. Based on the equation for a constraint, constraints are classified into two types: holonomic constraint and non-holonomic constraint. If the constraint equation can be expressed in the form of an equation, then we call it as holonomic constraint. If the constraint motion cannot be expressed in the form of an equation, we call it as non-holonomic constraint. Holonomic constraints are integral differential equations of constraints, whereas non-holonomic are non-integral differential equations. Examples of holonomic constraints. The motion of a point mass of a simple pendulum is an example of holonomic constraint. The constraint involved when a particle is restricted to move along a curve of a surface is an holonomic constraint. The distance between the two particles in the motion of a rigid body is an example of holonomic constraint. Examples for non-holonomic constraint. The constraint involved in the motion of a particle placed on the surface of a solid sphere is an example for non-holonomic constraint. The constraint involved in the motion of a molecule in a gas container is an example for non-holonomic constraint. An object rolling on a surface without slipping is an example for non-holonomic constraints. So students, in this session we learned what do you mean by constraint. That is, the limitations or restriction on the motion of a system are called constraint, and the motion is said to be constrained motion. Two types, namely holonomic and non-holonomic constraint. So now let's have a small MCQs. Question number 1. Constrained motion is a limitation or a restriction of A or B or none of the above. You know that it is a limitations or restriction. So the answer is C, A or B. Question number 2. Motion of a restricted body is known as, you know that it is a constrained motion. Question number 3. Constraint that can be expressed in the form of an equation is known as, what type of a constraint? It is holonomic constraint. Question number 4. Constraints that cannot be expressed in the form of an equation is known as non-holonomic constraint. Constraints that are integrable differential form of equation is known as holonomic constraint. Constraints that are non-integrable differential form of equation is known as non-holonomic. The constraints involved in the motion of a point mass of a simple pendulum is, it is an example for holonomic constraint. The motion of a bead of an hibiscus in which the beads can move along the smooth wire is an example of non-holonomic constraint. The constraint involved in the motion of a rigid body in which the distance between the two particles is always fixed is an example for holonomic constraint. The constraints involved in the motion of the molecules in a gas container is an example for non-holonomic constraint. So students, in this session we learned what do you mean by constraint, what are the types of constraint, and examples. So for more information you can refer Classical Mechanics by Goldstein, Classical Mechanics by J.C. Upadhyay, Classical Mechanics by Takwale and Puranik. Thank you all. Hope you enjoyed this session.